All right, I'm going to go over quickly some stuff here on Unit 1 that I want you to be aware of. You, of course, can read your text and follow along with that too. But the way the textbook is parted out, every unit begins with the learning objectives that's in there and a list of terminology. So it is your responsibility there to make sure that you are familiar with all of these terms. So if you don't, as you start a new unit, kind of glance over that and get an idea. If you're not sure what some of these terms are, then definitely come back in and discuss them or find out on your own there what they actually mean. But we will stick pretty much with the learning objectives behind each of these units. So, prints are a universal language. I mentioned that in class already. It is the main form of communicating both product design and, of course, the intent or the purpose of what a product design should be. So, and we use this widely throughout the manufacturing industry. So the moment of truth, of course, comes down, and when we start to get into more GD&T standards, that all kind of comes together as far as what we refer to as the interchangeability of parts, concept that's been around since the Industrial Revolution, and of course it's gotten refined and gotten better and better. So it doesn't, if we don't have some standards here in our prints and the way we do this, then it becomes difficult for prints to go from one manufacturer to another, or from a designer to a manufacturer. Needs to be made. And of course, in large assemblies with large products out there, you might have 20, 30 different manufacturers all making parts, all coming together to be assembled someplace. And so it's important that we know and understand and can read blueprints and be able to interpret them as well. Now, when we're talking about these drawings, what we're going to be going through is for each drawing, you should be able to identify the size, shape, tolerance, materials, different surface finishes, different types of treatments, whether they're heat treatment or galvanic treatment, all sorts of different things that are going to be in that print and shown, and that object needs to be fully defined. And we use blueprints to fully define that object so that the people who need to make it can make it correctly. Now, from the very beginning, I've been involved in industry for 30 years now, and from the start of my apprenticeship, day one, I was always told we make parts to print. So, and that is a mantra that we use. So we will refer to that print over and over again to make sure that things are correct. In addition to that, there is a contractual agreement. So between the person who designs the print and whoever the manufacturer there is that they're sending that print out to be manufactured by. So because of that, we've got a lot of things that we need to be able to do because, companies can get sued. People can get hurt when things aren't followed through and aren't made the way they are supposed to be made. So we've got to know how to read and interpret that to do it. So just as a case in point, if a design engineer is kind of being lax and doesn't really know about the standards and doesn't really know how to fully define that part and make sure that everything is spelled out, and that print gets released to a machine shop to make it, the machine shop makes it to the way the print is spelled out and then ships it. And once the designer gets that, or gets it and realizes, hey, these parts don't go together the way that they were intended, well, who's at fault? Well, if it's been made according to print, the person who designed it is at fault, and then that's up to them to correct and fix and still meet their financial obligations. However, if the print is correct and the machine shop that's made the part makes it incorrectly, well, then that's on the machine shop, and they either need to make it over or reimbursed the company that they were making that part for should any other damages and so forth occur. So there can be a huge financial implication behind these prints. So this is why most companies send their employees to some type of course to learn how to read and interpret these prints. And of course, if you're involved in manufacturing of it, if you're on the shop floor, if you're a machinist, a tool maker, if you are a electrician that's kind of reading prints in that regard. If you're the welder welding you need to know how to look at these, read them, and be able to assemble them. Even an inspector or quality control person needs to look and confirm that everything is the way it's supposed to be. And going into the office, purchasing agents, a lot of times purchasing agents will need to buy parts, so they need to be able to look and review and make sure that the parts that they're ordering from a contract manufacturer are indeed being made the way that they should be, and that we're getting good quality from it. So there's a lot of importance placed on these prints. And we got to pay attention to that. All right, so what is a blueprint? Here's a nice drawing, several types of blueprints. Predominantly in this course, we are geared towards mechanical prints. So let's go into a little bit more about that, and we'll talk about the difference between drafting versus blueprint reading in CAD. Now, I have always made this remark: 100% of tradespeople or people involved in manufacturing need to know how to read a blueprint. So not everybody needs to know how to do drafting or CAD. So, and what is the difference? And there are different skill sets. You guys are taking the blueprint reading class, so you are going to learn how to look at a print, how to pull information off of it so that you can make that. The drafts person or the drafter is looking at it from a different standpoint. And lots of times we, in manufacturing, whether you are in an office or even if you're in academia, we tend to think that if you know how to draft it, then you know how to read it. And that's not necessarily true, because drafting, board drafting the way I was traditionally trained, or even going into CAD, which is the way things are done now, computer-aided drafting, there are still standards that have to be followed, and we need to be able to put those standards in the drawing. Now, unfortunately, when most people take a CAD class, we spend and have to spend a lot of time just teaching you how to create the drawing or how to create CAD. And in today's modern 3D CAD, that doesn't always lend itself to how that blueprint should look. So everybody does need some due diligence. Hopefully, some of you will go on to learn how to draft and how to draw in CAD, and then there's some due diligence on the part of the CAD designer to also make sure that they know what the industry standards are. They know how to lay out the front, top view, any auxiliary or section views, and basically put it on a print so that it can be readable and understood by the workers that are making that part as well. All right, let's talk a little bit. Industry is constantly changing. This is a little bit different too. So there are some differences here in terms of printers, plotters, and the types of images that created by CAD systems. So, and whether we get vectors or raster images out of it. Now, as somebody who is reading the print, understand, for you, the main thing for you to understand is that one time when the way prints are, once they're drafted up in CAD, they are sent to some type of a printer or plotter to basically print those paper copy prints out. Now, most of industry is changing over more towards electronic files and looking at the computer. So this is also an area of change. How much this will still be around in another 5 or 10 years, I can't really say at this point. Some companies are still using this. Other companies have switched over entirely to looking at prints on a computer. This is just 5 steps of the design process, just to understand. First, we got to state the problem. We'll brainstorm to figure out a bunch of possible solutions, kind of come through, refine some solutions, create prototype, do some testing analysis on it, implement it, and kind of any time there's a breakdown or anything, we go back to the previous step, or we go back to the statement of problem and redo it. So if you ever go into a design class, we'll take many, many more classes on that. So here are the steps to reading a print. So first we're going to read the title of the part, check the drawing number, read the title block and the notes, read any specific callouts or extra specifications. We're going to check for revisions and any design chain notes, and then we're going to actually start to look at and analyze the overall part or the assembly drawing. So this is a pretty good guide. I will say I don't always do it in this step, but you do need to be aware of where to find and pull out all this information from a print as you're going through. On the care side of the prints, make sure that we don't write on a print, so we don't get it dirty. We want to keep it clean. Prints, if they are actual paper copy prints, they do get stored in file cabinets. The larger print sizes then will get folded and unfolded, so you do want to be careful in that process to make sure that you're maintaining and keeping those prints in good condition as they do move about from the factory floor. Likewise, don't lay any sharp tools or dirty machine parts or other objects on top of the print that might cause oil or dirt to get on stuff and impede the view from the other people that would need to be the print. Now, I will say in modern day, how many companies are still having paper prints that go around the shop floor? I'm not sure. A lot of companies have been have converted over to computers all the way, but there are still companies out there that are working on paper copies of a print. So make sure that you're aware of that as you go through.